Hello everyone. Welcome to this video on learning mathematics through concepts and examples. In this video, we are going to learn integration using U-substitution. So before we begin with the example, I just want to give you a quick scenario here so that we have the idea on when to use the U-substitution. So if you have a function, and some multiple of the derivative of this function, okay, when I say some multiple, it can be some k times the derivative of the function. Okay, if you have a function and the multiple of the derivative of the function as an integrand, that means if we are integrating this one with respect to x, then we can use the U substitution to evaluate those type of integral. Remember, basically, the function over here, the f of x, will be a composite function. If that function is a composite function and the derivative of that inside function is here along with some multiple, then we can use the U substitution. Remember, sometimes the exact derivative of that inside function may not be there. So we may have to do a little bit of manipulation to make the situation fit the condition for the U substitution and use it. Let's see. Let's go to first example and try to do that. So here is the first one. Find the integral, which is integration from t raised to 9 sine t to the 10 dt. So if you look at this carefully, what we have is one of the functions is sine t to the power of 10. So that is the composite function. And the derivative of this inside function would be 10 times t to the 9. But here we have t to the 9 dt. T to the 9. Okay, let me write like this, t to the 9 dt. So we can rewrite the given function like that. So function, and that is the derivative, but not the complete derivative of the inside function. The derivative of the inside function t to the 10 would be 10 t to the 9. So 10 is missing, so here we can multiply by 10. If we multiply by 10 and 1/10 outside, we are not changing the value of the integral. 1/10 times 10 is just a 1. So we can rewrite that integral like this. Now it is ready for U substitution. And what we can do is U is always equal to this inside function. But in this example, to make your life easy, they have already given this one, U equal to t to the 10. So sometimes this condition will not be given. In that case, we consider that inside function as U. So let's do that as a side work here. So let U equal to t to the 10. So we find the derivative. So derivative of U with respect to t, du over dt. Du over dt is equal to, we can find the derivative using the power rule. So 10 will come in front and we reduce the power by 1. So 10 t to the 9. Now if you multiply on both sides by dt, you get du equal to 10 t to the 9 dt. This quantity here, which is in the second parenthesis, 10 t to the 9 dt is du. So now we can make the substitution. So this is equal to 1 over 10 is outside, integration of sine t to the 10 is a u, and then 10 t to the 9 dt, 10 t to the 9 dt is a du. So that is du, which is equal to 1 over 10. And then the integration of sine, here we are integrating the sine. Integration of sine u is negative cosine u, negative cosine u. And this is the indefinite integral, so we need plus c at the end, plus c. So this is my final, this is my answer, but not the final answer, because our final answer should be in terms of u. So 1/10 with that negative, that becomes negative 1 over 10. Cosine u is t to the 10, okay, plus c. So now that is my final answer. Okay, that is my final answer. Negative 1 over 10 cosine t to the 10 plus c. That's first example. So here we use U substitution to evaluate the indefinite integral. So we are going to look at the examples like this throughout the video so that you'll be confident with the U substitution. Okay, here's the next example. So if we look at this, what we have is we have integration of 8 over the square root of 8x squared plus 3 dx. Now you can see that the function is a composite function. It's a square root function with 8x squared plus 3 inside. So this type of integral can be evaluated using U substitution, where U is the inside function. So that will be your U. But if you look at this, we have the inside function is 8x squared plus 3, that will be U, and the derivative of that will be 16x. Okay, hold on, this is a x there. I wrote a 8. Okay, that's an x. So the derivative will be 16x, but I just have an x there. So what we do is we can rewrite it like this. Integration, in the denominator we have 8x squared plus 3. Now in the numerator, we can write that as 8 times x, and there is also a dx. 8 times x dx. So we multiply by 8. That means we also need to multiply by 1/8, so that 8 times 1/8 will be just 1, and nothing is changed. And we are ready for U substitution. U equal to that inside function. So let's do it. Let U equal to 8x squared plus 3. So the derivative du over dx is equal to 16x, or if you multiply on both sides by dx, you get du equal to 16x dx. This 16x dx is almost the numerator. There is an 8. So what we can do is, I accidentally multiplied by 8. It should be multiplied by 16, in fact. So if there is a 16, and here also 16, it matches. That was my bad, because 8 times 2 is 16. 16x should be there, so I have to multiply by 16. Okay, now let's make the substitution. 1 over 16 and square root of, in the denominator, square root of u, because 8x squared plus 3 is a u, and the numerator 16x dx is a du. Okay, I can write like this: 1 over 8 times the integration of 1 over 2 square root of u du, because 8 times 2 is 16. And the reason I wrote like this is 1 over 2 root u. I know the integration of 1 over 2 times the square root of u. That is square root of u. And then we add plus c, because the derivative of square root of u is 1 over 2 square root of u. So the integration of that will be u. So in order to fit that situation, I just split that 16 to 8 and 2, 8 times 2. And then du, I wrote 1 times du. That is my answer, but not the final answer. Final answer should be in terms of x. So it will be 1 over 8 square root of u is 8x squared plus 3. And at the end, we have a plus c. So this is how we can use U substitution to find the improper integral. That is example 2. Time for example 3. So here is our example 3. So here we have integration of 2y minus 5 raised to 5 dy. So this is a composite function. We can basically try to use the U substitution. U will be the inside function. And the derivative of inside function, 2y minus 5, is a 2, which is not here in the problem. So we can rewrite it like this. We can write this as integration of 2y minus 5 raised to 5 times 2 dy. Okay, we can multiply here by 2. Okay, we can multiply here by 2 dy, because the derivative of 2y minus 5 will be 2. But this 2 was not there. So in order to balance, we also need to multiply by 1 over 2, because 1 over 2 multiplied to 2 is a 1. Now we are ready for U substitution. And U is the inside function. U is 2y minus 5, which is already given to you. So let U equal to 2y minus 5. So the derivative du over dy is equal to 2. Or if you multiply on both sides by dy, you get du equal to 2 dy. That is the quantity inside the second parenthesis. Look at that, 2 dy. That's a du. So let's make that substitution. So we have a half integration of 2y minus 5 is a u. So that becomes u to the 5 or u raised to the power 5. And 2 dy is a du, which is equal to half multiplied to, if we integrate this, we increase the power by 1 and divide by the new power plus c. So that is my answer, but not the final answer. So what we do is for the final answer, 1 over 2, and there is 6 in the denominator, that becomes 1 over 12. 1 over 12. U is 2y minus 5 raised to the power 6 plus c. That is my final answer. Okay, so here also we use the U-substitution to evaluate the indefinite integral. Okay, I think you start getting a little bit of U-substitution. We'll do a few more examples today. Example 4. So in this one, we are asked to find the indefinite integral for this function using U-substitution. They have already given U, but you may or may not get this all the time. So if we look at the question, we have integration of 2 cosine cubed t dt. This one I'm going to break it a little bit. So I'm going to rewrite this as 2 times cosine squared t times cosine t dt. Furthermore, I want to pull that 2 out. Cosine squared is 1 minus sine squared t times cosine t dt. Now we are ready for U substitution, because you can see that if we consider U as a sine, okay, if we consider U as the sine, then the derivative of sine will be cosine t, which is here. So what I mean by that is, let's see, let me write here. Let U equal to sine t. That means du over dx is equal to derivative of sine is cosine t, or du will be equal to, if we multiply by dx, it will be cosine t. We are differentiating with respect to t, so that's a dt, cosine t dt. So you can see cosine t dt, which is the second parenthesis, is a du. Okay, so let's do it here at the side. So our integral becomes 2 is there as it is. We can keep that 2 as it is. And then we have 1 minus t squared. So that becomes 1 minus u squared. 1 minus u squared. And then we have cosine t dt. Cosine t dt is du. Now, if you simplify, we have 2 times integration of 1 with respect to u is a u. And then minus integration of u squared with respect to u is u cubed over 3. U cubed over 3 plus c. Now we can distribute that 2. So it becomes 2u minus 2/3 u cubed plus c. That's my answer, but not the final answer. Final answer should be in terms of t. So I need to resubstitute the value of u, which is equal to sine t. So that becomes 2 sine t. 2u means 2 sine t minus 2/3 u cubed means sine cubed t plus c. Okay, so that is the derivative. And again, we use the U substitution. That is example 4. Let's move on to example 5. Here is example 5. So here what we have is, we have integration of 2y minus 9 raised to negative 7 dy. Now, if you look at that carefully, what you'll see is, this is a composite function where the inside function is 2y minus 9. And the derivative of inside function will be 2, which is missing in the integrand. So we basically multiply by 2 and also multiply by half, because half times 2 is 1 and we are not changing anything. That means by doing that, we are ready for U substitution. And U is the inside function, which is 2y minus 9. So let U equal to 2y minus 9. We find the derivative du over dx equal to 2, or you get du equal to 2 dx. So we get du equal to 2d. So here it is du over dy, by the way, because there is not x, there is a y. So du over dy. So that will be 2 dy when you multiply. And this one, 2 dy, is the second parenthesis that is there. So we can make that substitution. So we get half, and then integration of, this is your u raised to negative 7, u raised to negative 7, and then 2 dy is du. So it is easy to integrate this one. Half, we increase the power by 1, that becomes negative 6. We divide by the new power and then plus c. This is my answer, but not the final answer. 1/2 and negative 6 in the denominator, that is negative 1 over 12. The value of u is 2y minus 9, power is negative 6 plus c. So that is our answer. Okay, that's how we can find the value of the integral. Okay, number 5 is that. Let's move on to number 6. So number 6 involve the u substitution with trig function, and this is the definite integral, by the way. So you can see that we have 0 up to pi over 4, okay? 0 up to pi over 4, we have tangent 3t. Let me write that part first. Tangent 3t multiplied to secant squared 3t, and there is also dt. I'm writing like that. Now what I'm thinking is I'm going to use u as tangent t, and derivative of tangent is secant squared, which is here, secant squared 3t, but the only thing missing is derivative of tangent 3t will be 3 secant squared 3t. So I'm missing a 3 there. So I can do it this way. Then I can use the u substitution. So u is equal to tangent t. So we consider let u equal to tangent t. So we find du over dt, but here the tangent, the value of t or the angle is 3t, so tangent 3t. So the derivative will be equal to 3 secant squared 3t. And if you multiply by dt on both sides, du equal to 3 secant squared 3t dt, which is the second bracket here. This bracket is 3 secant squared 3t dt. So now there are a couple of things that we need to take care here. 1/3, and then tangent t is simply u. Okay, tangent t is u, and this one is du. And you can clearly see that we make this integral very, very simple. That integral we make is very, very simple. But remember one thing. In the original integral, we are integrating with respect to t, so these limits are the values of t. But now we are integrating with respect to u, so we need to find the values of u as the limit. And we can use this equation to find that. If you plug in lower limit 0, that means u equal to tangent 3 times 0. Tangent 0 is 0. So the lower limit will be 0. And then if you plug in the upper limit, u will be equal to tangent 3 pi over 4, which is a -1. So that integral becomes this one. They said use the change of variable. We change the variable t to variable u. So that's a u substitution. If you see the change of variable, you are using the u substitution there. Now you can integrate this easily. This is equal to, see, 1/3 as it is. Integration of u is squared over 2, evaluated between 0 and 1, 0 and -1. So we use the fundamental theorem of calculus to evaluate this. So if you plug in the upper limit, -1, so this one is 1/6, okay, 1/3, and 2 in the denominator, 1/6 of -1 squared, that is 1/6. Subtract and plug in 0. If you plug in 0, 0 squared is 0. 0 times that 1/6, that is a 0. That means 1/6 minus 0 is 1/6. So the given integral, the value of the given integral, given definite integral, is 1/6 using U substitution or using change of variables. We change the variable t to variable u and we simplify that. Okay, that is our 6th example. 3 more to go. So we did the 6th one. Now we are ready for the 7th example. Okay, example 7. Compute the indefinite integral which is given here. So here we have the indefinite integral e raised to -3x dx. This is also the composite function. The exponential function is the outside function. The inside function is the linear function -3x. But the derivative of this inside function is not here in this problem. So what you do is, first we try to write that. So that means what I'm going to do is, I'm going to rewrite it like this, e to the -3x, and I have a dx, but I'm going to multiply by the derivative, which is a -3. Okay, -3 dx. So because I'm multiplying by -3, I also need to multiply here by -1/3, so that -1/3 times -3 is a 1, and there is no change in the question. But now we are ready for the U substitution, where U equal to -3x. So we say that U is equal to -3x. So we are differentiating U with respect to x, which is equal to -3. And if we multiply on both sides by dx, you get du equal to -3 dx. And this -3 dx is the same as the value here in the parenthesis. So the substitution will be easier. So we have -1/3 integration of e raised to -3x is a u, and then -3 dx is a du. And this is equal to -1/3. We know that integration of e to the u is e to the u, because derivative of e to the u is e to the u, plus c. That's my answer, but not the final answer. I need to write my final answer in terms of the given variable x. So I have to resubstitute the value of u. So the final answer will be -1/3 e to the u is -3x plus c. So here also what we did is we use the u substitution to evaluate the given integral. Okay. Time for example 8. Here we are asked to find the indefinite integral, which is given here. And I'm going to use the u substitution here because that's the goal of our video. So here we have integration of 40 e raised to 8z dz. Now, this one, e raised to 8z is a composite function. Outside function is the exponential function. Inside function is 8z. And the derivative of 8z is 8. So that 8 is not here. Instead, we have a 40. We have a multiple of that. So we need to rewrite this a little bit. So we can rewrite it like this. We can write 5 times e raised to 8z times 8 dz. Because 5 times 8 is a 40. So I'm just writing that 40 as 5 and 8 there. 5 times 8 is 40. So we are just rewriting that integral like that. And we are ready for u substitution. U is equal to 8z. Let u is equal to 8z. That means du over dz is equal to 8. And if you multiply on both sides by dz, you get du equal to 8 dz, which is the quantity inside that parenthesis. So now the substitution will be very easy. So we have a 5, then integration of e raised to 8z is u. and 8dz is du. E raised to 8z, so 8z is u, so e raised to u, and 8dz is a du. Integration of e to the u is e to the u, and then we add plus c. That's my answer, but not the final answer. All I need to do is I need to rewrite the value of u. Resubstitute 5 is equal to e raised to u is 8z plus c. That's my answer. So you can see that we also evaluated this exponential function, integrated the exponential function using the U-substitution. Second last example for the day, example 9, we are asked to integrate this one. So here we have integration of dx over 2x minus 5. You can see that in the denominator we have 2x minus 5. The derivative of 2x minus 5 is 2, which is missing in this integral. So we can rewrite it like this. Dx over 2x minus 5. Derivative of 2x minus 5 is 2. So we can write 2 dx. If we multiply by 2 here, I also need to multiply by half. So that half times 2 is a 1. So I'm not changing the value of the integral. But by doing that, we are ready for U substitution. So we can write u equal to 2x minus 5. So you can find the derivative du over dx, which is equal to 2. And if you multiply on both sides by dx, you get du equal to 2 dx. Okay, du equal to 2 dx, which is that numerator. So we can substitute. We have a half, and then integration of denominator is u. I can write the denominator first. 1 over u if I just want to write the denominator. And 2 dx is du. Half as it is. We know that the derivative of natural log x is natural log u is 1 over u. So integration of 1 over u will be natural log u. And then plus c. I write the absolute value because I don't know the value of u. If u is negative, log function will not be defined. That's why, just to be safe, I use the absolute value. So half times the natural log of absolute value of u plus c. That's my answer, but that's not the final answer. I need to rewrite the value of u, which is 2x minus 5. So this is equal to half times the natural log of absolute value of 2x minus 5 plus c. So that is our final answer for this one. And here also, we use the U substitution. So up to this example, we are using the U substitution, okay? We are using the U substitution, and we'll continue to do that in next example also. Okay, so that was the ninth example. Okay, that was the ninth example. Now is the time for 10th example. We want to do example 10 using the U substitution again. So let's see how we can use U substitution for that number 10. Okay, time for number 10. Okay, so here we have, let me write this definite integral. I mean, indefinite integral. We have integration of, in the denominator, we have natural log x squared. So I'm going to write that as 1 over natural log x squared. And then this 6, I want to pull it outside. 6 is a constant, I can take it out. Then what is remaining is x in the denominator and dx in the numerator, which can be written as 1 over x dx. By writing like this, you can clearly see that we can use the U substitution. Because if this is the composite function, the inside function is natural log x. And you know that the derivative of natural log x is 1 over x, which is also here. So that's why we can consider u equal to natural log x and solve this one. So let's do it here at the side. Let u is equal to natural log x. So that means du over dx will be equal to 1 over x. If I multiply on both sides by dx, So you get du equal to 1 over x dx, which is this second parenthesis, 1 over x dx. So now we have 6 times 1 over natural log x is u with the squared, so u is squared. And then 1 over x dx is a du, Now we can integrate this using the power rule. So if we integrate using the power rule, we get negative 6 over u and then plus c. Okay, by integrating this one using the power rule, we get negative 6 over u plus c. This is my answer, but not the final answer because it is in terms of u, but our question is in terms of x. So I need to resubstitute the value of u, which is natural log x. So this will be equal to negative 6 over natural log x plus c. So that is my final answer. So this is how you can use U-substitution to evaluate the indefinite and also definite integral. That's all for this video. Thank you so much for watching, and I hope you find this helpful.